Hello everyone, I'm Sandeep Matthias and I will be presenting our paper Happy Are Those Who Grade Without Seeing, a multitask learning approach to grade essays using gaze behavior. An essay is basically a piece of text written in response to a topic called the essay prompt. The process of assigning a score to the essay is called essay grading, and if we use machines, the process is called automatic essay grading. Cognitively aided automatic essay grading is when we use cognitive information to help the machine in performing automatic essay grading. This slide covers some of the basic terminologies with regard to gaze behavior. An interest area is a part of the screen which is of interest for analysis. In our example here, the interest areas are the red rectangles. A fixation is an event where the reader focuses on a part of the screen. In this image, the fixations are represented as light blue circles. Saccades are the movements of the eye from one fixation to the next. These are represented here by the dark yellow arrows. There are two types of saccades, progressions and regressions. A progression is a saccade from the current interest area to a future or later interest area, and a regression is a saccade from the current interest area to an earlier interest area. So we basically know that gaze behavior can help improve the performance of NLP systems for a variety of tasks, but collecting gaze behavior is costly in terms of time and money. There are a couple of solutions. The first is type aggregation from an existing gaze behavior dataset, which is basically the gaze behavior of each token is calculated as the mean value of the gaze behavior for that token in the gaze behavior dataset. And the second is multitask learning, where learning gaze behavior is an auxiliary task and the NLP task is the primary task. So this slide consists of a list of related work in the area of holistic automatic essay grading as well as eye tracking. We had an earlier paper in 2018 which used eye tracking to predict how a reader would rate the quality of text. But in that approach, we collected gaze behavior for all the text, whereas in this, we collect gaze behavior for only some of the text. Multitask learning is basically the approach which we use. It's a machine learning paradigm where we use information from auxiliary tasks to help in solving a primary task. In our approach, we collect gaze behavior for a very small number of essays and use that gaze behavior data to help in training a model to score other essays. So here, scoring the essay is the primary task and learning the gaze behavior is the auxiliary task. This slide consists of the statistics for our data set. We use the ASAP automatic essay grading data set, which has 8 prompts, each containing between 700 to 1800 essays for a total of about 13,000 essays. We collect gaze behavior for only 48 out of the 13,000 essays across the four source dependent response prompts. So this is the summary of our data gaze behavior dataset details. We use 12 essays from each prompt, and the maximum words of the essays that we use is 250. And we collect essays for each of the different score levels for each of the different prompts. Seen essay sets and unseen essay sets are basically as differentiated as follows. Seen essay sets are essay sets where we collect gaze behavior for 12 essays of varying essay score, and unseen essay sets are essay sets where we have no gaze data available at all. For the seen essay sets, we use the source dependent essays for two main reasons. The first is these essays are short enough to be displayed entirely on the screen, even for very large essays. And the second is that the original dataset has the named entities anonymized. So if with the source article we are able to correctly de-anonymize the named entities. We collect the gaze behavior for 8 annotators aged between 18 to 31 with an average age of 25, and we evaluate their performance across three metrics. The first is the quadratic weighted kappa agreement between the annotator and the ground truth score. The second is the correct, which is the number of times where the annotator scored the essay the same as the ground truth score. And the third is close, which is the number of times the annotator differed by at most one with the ground truth score. We have three different types of gaze behavior attributes. The first are fixation attributes, which is mainly the dwell time and first fixation duration. Then the second is the is regression attribute, which is to see whether or not there was a regression from the current interest area. And the third is the interest area attributes, namely run count and skip, which is the number of times the interest area was fixated on and whether or not the interest area was skipped. We use two systems. The first system is a modification of Dong et al.'s 2017 self-attention system. In this, we split the essay into sentences, and each sentence is given as input to the embedding layer, and the output is the word embeddings. The word level CNN layer takes the word embeddings as input and sends the output to an attention pooling layer. The output of the attention pooling layer is the sentence level representation. Each of these sentence level representations are then sent through a sentence level LSTM, and the output of that is pulled through an attention pooling layer to get the representation for the essay. Since gaze behavior is basically a word level feature, we learn the gaze behavior at the word level CNN layer, and since the score is given for the entire essay as a whole, the essay representation is sent through a dense layer to get the score. This slide shows our second system, the co-attention based system, which is similar to the system developed by Zhang and Littman in 2018. We just like Dong et al. 2017, we get a representation for the essay, and what Zhang and Littman also do is they get a representation for the article, and then send the representations to a co-attention layer, and then a modeling layer, and finally an output layer to get the essay score. Just like the earlier approach, we also collect the gaze behavior data at the word level CNN layer. This slide shows the list of hyperparameters that we use for each of the layers in our system. In addition to the hyperparameters used by Zhang and Littman and Dong et al., we also attach weights to each of the gaze features. We attach a weight of 0.05 to the dwell time and first fixation duration, zero point zero 0.01 to the is regression and run count features, and zero point 0.1 for the skip attribute. We run two sets of experiments. The first is on the seen assay sets, and the second set of experiments is on the unseen assay sets, where we use only the self-attention system. The three experiments which we use on the seen essay sets are self-attention, which is a single task learning approach of scoring the essay using only the self-attention system. Co-attention, which is a single task learning of scoring the essay using co-attention. And co-attention plus gaze, which is the multitask learning system where we score the essay as well as learn the gaze behavior. Similarly, for the unseen essay sets, we use only self attention because there are no corresponding source articles in them. The first is the only prompt system where the training data only contains essays from the given prompt. The second is the promptless essay system, where it contains the data from the given prompt plus the 48 essays where we have gaze data. And the third is prompt plus essays plus gaze, which is the training data uh, containing essays from the given prompt plus the 48 essays where we have gaze data plus the corresponding gaze data for those essays. We evaluate our systems using fivefold cross validation with quadratic weighted kappa as the evaluation metric. Since each of the readers read the essays at different speeds, we use binning to normalize the gaze attributes across different readers. So is regression and skip count, which are binary features, are either 0 or 1 bins. Run count has 6 bins, which are numbered from 0 to 5, corresponding to run counts of 0, 1, 2, 3, 4. And bin 5 basically corresponds to run counts that are greater than 4. Dwell time and first fixation duration have 6 bins numbered from 0 to 5, and these are numbered as follows. It is 0 if the fixation value is 0. That means that the reader hasn't fixated on that interest area. And it is 1 if it is between 0 and mu minus sigma, 2 if it is between mu minus sigma and mu minus zero point 0.5 sigma, and so on. So here mu denotes the mean value for the fixations, and sigma denotes the standard deviation for the fixations for a given reader. These are the results of our systems compared with other state of the art systems on the scene assay sets. So here you see that we are uh, the achieving statistically significant improvements over the baseline co-attention system of Zhang and Littman. In the unseen assay sets, we also see statistically significant improvements over 2 out of the 4 prompts. We also ran experiments using a native speaker alone. So here from this table we see that the results where we use the gaze behavior of the native speaker are better than using no gaze behavior at all, but they're still worse than when we use the gaze behavior of all the speak annotators. To find out which of the gaze behavior attributes are the most important, we also run ablation tests. And here we see that the most important attributes happen to be the fixation based attributes, namely the dwell time and the first fixation duration. So this slide basically is a heat map for the dwell time of a reader as they read one of the passages. So you can see that the darker shades of blue, which correspond to longer dwell times, are mainly things that are out of context words like bay instead of buy, incorrect phrases like new haze instead of now has, and spelling mistakes like map instead of map. So, in conclusion, we show that learning gaze behavior as an auxiliary task leads to statistically significant improvements in automatic essay grading. We learned that the most important gaze behavior attributes for this particular task are fixation based attributes, namely dwell time and first fixation and duration. In the future, we plan to explore how we can use gaze behavior for tasks like cross domain AEG or zero shot AEG, where we have no prompt specific essays available at training time. Thank you. Any questions?